Question number 29. A rectangular coil rotates at a constant angular velocity omega, and at an instant shown, the plane of the coil is at right angles to the line C dash. Z dash is like this. I don't think I'll take this step forward. Right? I take it like this over here. So this is your rectangular coil, similar to what has been shown over here. Where is your y dash? Y dash is this is your y dash. And where is your z dash? Z dash is the line that passes to the center of this one here, like this over here. And where is the x dash? The x dash is along this line. Okay, along this line. Okay. Now the variation of EMF with time is shown. What coil rotation about the axis produces this graph? How do you rotate it so that you get the particular graph? 3-dimension converted to 1-dimension. 2-dimension. You need to think about it like this. Now what we do is, now where is the aerial vector? So this is your magnetic field. Now what is your magnetic field? Where is your aerial vector? Aerial vector would be like this or like this. Now let me assume I rotate it like this. I rotate it like this. If I rotate it like this, is there any change in the flux? How do you understand this? How do you answer this? If I rotate it like this, because you know this is your magnetic field. The magnetic field, when it is present like this, it is the area is not cutting the magnetic field lines. It is just parallel to this, and the aerial vector is perpendicular to this. Okay, as you know, the magnetic field vector is the phi vector is given by B dot A, which is nothing but BA cos theta. Okay, where B is one vector, A is another vector, theta is the angle between B and A. So therefore, see what is the B vector? B vector is like this over here. What is the A vector? A vector is either outward like this or inward like this. Both the cases are where the angle between B and A is always 90 degrees. In that case, there is no flux at all. Which means what? If you rotate it like this, then the B and A angle will never change, and it always is 90 degrees. So it will not show you any flux. And the flux is 0. If the flux is 0, EMF is always 0. So therefore, our assumption that this is rotating like this is incorrect. Now, how should it rotate? Now you know this is the magnetic field. So I can say it can rotate like this, or it can rotate like this. Now let me consider that point. Okay, that is the x dash. So which means what? So with respect to the center, it's now rotating like this. If it is rotating like this, what will happen? This is your magnetic field. The aerial vector initially was pointing like this. Now when I keep it like this, aerial vector is here. When I keep it here, aerial vector is here. Then aerial vector is here. So every time, see for example, if I keep it here, no field lines are cutting. Okay. If I keep it here, maybe 10 lines are cutting, 20 lines are cutting, 50 lines are cutting, 40 lines are cutting, 30 lines are cutting, 0 lines. Then again 10 lines are cutting. Right. So therefore somewhere as I rotate it like this, there is a possibility that magnetic field lines are cutting, and there is a phi value which is alternating. There is an EMF value which is also alternating. So definitely the direction has to be along the x dash, not z dash. So along the x dash. See, I keep it like this. See, this is my x dash, right? So this line is my x dash. This is my x dash. So it is now rotated like this. So this is my x dash, and hence now you can see. Okay, so these two are incorrect. These two are incorrect. It should be between these two. Now let us look at what is the magnitude. Now when you have something like this, initially it is like this over here, and when you rotate it over here, see, when you have it like this over here, and you rotate it over here, you're rotating it by 90 degrees or maybe 180 degrees, 270 degrees, that's what it tells you. Now let me draw this figure. So therefore, now at t equal to 0, your EMF was 0. So which means what? So EMF was high. Okay, now at t equal to 0, EMF is high. But the flux is equal to 0. Only the EMF will be high, right? Okay. So as a result of it, when is it possible? I keep the sheet over here. The flux is 0 in this direction. Okay. Currently the flux is 0. Now at t, when this becomes perpendicular like this, more amount of flux is passing. When more amount of flux is passing, EMF would be 0, right? EMF is 0. Therefore at t is equal to, let me call this point t. T equal to t, EMF is 0, flux is high. Now what is the angle made by this armature? Okay, in rotating from this position to this position. See, this position to this position. It is seen to be how much? 90 degrees, right? 90 degrees. So now the coil becomes something like this. Here, and as a result of this, so it becomes 90 degrees. Okay, so when it becomes 90 degrees, it means you have to rotate this one to 90 degrees only, then you get that kind of graph. This answer is A.